Good morning, students. Welcome to 11th Standard Chemistry video class. In this video, we have to start with the new lesson, Unit 7, Thermodynamics. It is present in your Chemistry Volume 1 book. First, we will start with Introduction to the lesson, Thermodynamics. Introduction. The term thermodynamics means flow of heat. The word thermodynamics is derived from the Greek word. Thermos means heat, dynamics means flow. Hence, thermodynamics means flow of heat. In our daily life, we come across with many useful reactions. For example, burning of fuel to produce heat energy, which means heat energy is produced when fuel is burnt. Next one, flow of electron through circuit to produce electrical energy, which means electrical energy is produced when electron flows through the circuit. Finally, metabolic reactions to produce the necessary energy for biological functions and so on, which means energy necessary for biological function are produced by metabolic reactions. So, in this lesson, thermodynamics, the study of transformation of energy, explains all such processes quantitatively and allows us to make useful predictions. In steam engine, heat energy is converted to mechanical work. The laws of thermodynamics were developed and helped to understand the process of steam engine. Hence, thermodynamics laws were developed and helped to understand the process of steam engine. These laws have been used to deduce powerful mathematical relationships applicable to a broad range of processes. It is explained in this paragraph. Thermodynamics evaluates the macroscopic properties, namely heat and work, and their interrelationships. Here, thermodynamics gives the relationship between heat and work. Thermodynamics deals with properties of system in equilibrium, and it does not depends on any theories or properties of the individual molecules which constitute the system. The principles of thermodynamics are based on three laws of thermodynamics, namely first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. The first two laws, namely first law and second law, explains the interconversion of different form of energy, where third law of thermodynamics deals with the calculation of entropy and the unattainability of absolute zero Kelvin. Even though thermodynamics carries high practical values, it has some limitations. It does not depend on atomic structure, molecular structure, and reaction mechanism. Thermodynamics law can be used to predict whether a particular reaction is feasible or not under a given set of conditions, which means whether the reaction takes place is possible or not. The thermodynamics law cannot give the rate at which the reaction takes place, which means it does not give at what speed the reaction takes place. In other words, thermodynamics deals with equilibrium conditions quantitatively but does not take into account the kinetic approach to the equilibrium state. It is explained in this paragraph. Before studying the laws of thermodynamics and their applications, it is important to understand the meaning of a few terms used frequently in thermodynamics. Let me discuss some terms used in thermodynamics, namely universe, system, surrounding, and boundary. Generally, universe is divided into two parts, namely system and surroundings. What is system? The system is the part of universe which is under thermodynamic consideration. It is separated from the rest of the universe by real or imaginary boundaries. If you see the diagram, it explains about system. The system is the part of universe which is under thermodynamic consideration. It is separated from the rest of the universe by real or imaginary boundaries. Next, let me discuss example for system. The system may be water in a beaker, a balloon filled with air, and aqueous solution of glucose, etc. Again, I repeat, example for system. The system may be water in a beaker, a balloon filled with air, and aqueous solution of glucose, etc. On basis of physical and chemical properties, systems can be divided into two types, namely homogeneous system and heterogeneous system. What is homogeneous system? A system is called homogeneous if the physical state of all its constituents are the same. For example, mixture of gases, completely miscible mixture of liquids, etc. Again, I repeat, a system is called homogeneous if the physical state of all its constituents are the same. Example, mixture of gases, completely miscible mixture of liquids, etc. Next one, what is heterogeneous system? A system is called heterogeneous if physical state of all its constituents is not the same. For example, mixture of oil and water. Again, I repeat, a system is called heterogeneous if physical state of all its constituents is not the same. Example, mixture of oil and water. Here, the physical state represents solid, liquid, and gases. Next, let me discuss surrounding. What is surrounding? Everything in the universe that is not the part of the system is called surroundings. In the universe other than the part of system is called surrounding. Next one, boundary. What is boundary? Anything which separates the system from its surrounding is called boundary. Anything which separates system and surrounding is called boundary. Hence, this picture gives the definition for system, surrounding, and boundary. Next topic, types of systems. There are three types of thermodynamic systems depending on the nature of the boundary. They are open system, closed system, and isolated system. Let me discuss one by one. First, let me discuss isolated system. Isolated system. A system which can exchange neither matter nor energy with its surrounding is called an isolated system. Here, there should be no exchange of matter and energy between system and surrounding. It is said to be isolated system. Here, the boundary is sealed and insulated. Hot water contained in a thermos flask is an example for an isolated system. In this isolated system, both energy and matter neither enter nor leave the system. Here, energy is heat energy, matter is water vapor. Both of these neither enter nor leave the system. It is the explanation given for isolated system. Next, let me discuss closed system. Closed system. A system which can exchange only energy but not matter with its surrounding is called closed system. Here, there should be only exchange of energy. There should be no exchange of matter between system and surrounding. Here, the boundary is sealed but not insulated. Hot water contained in a closed beaker is an example for a closed system. In this system, energy is transferred to the surrounding, but no matter can escape from this system. Here, energy is heat energy. Matter is water vapor. Heat energy is exchanged, but not the water vapor. It is explained for closed system. A gas contained in a cylinder fitted with a piston constitute a closed system. Next, let us discuss open system. Open system. A system which can exchange both matter and energy with its surrounding is called an open system. Here, there should be exchange of both matter and energy between system and surrounding. It is said to be open system. Hot water contained in an open beaker is an example for open system. In this system, both matter and energy is transferred to the surrounding. Here, matter is water vapor, energy is heat energy. Here, both heat energy and water vapor get exchanged between the system and surrounding. All living things and chemical reactions are open system because they exchange matter and energy with the surrounding. Here we completed open system. Let me conclude the topic. In isolated system, there is no exchange of both matter and energy. In closed system, there should be exchange of energy. There is no exchange of matter. In open system, there should be exchange of both matter and energy. Hence, we completed the topic types of thermodynamic systems. Next topic, properties of the system. Intensive and extensive properties. Some of the properties of a system depend on its mass or size, whereas other properties do not depend on its mass or size. Based on this, the properties of a system are grouped as extensive property and intensive property. Now, let us discuss what are extensive property and intensive property. Again, I repeat, based on the mass or size, the properties of a system are classified into extensive property and intensive property. Extensive properties. The property that depends on the mass or size of the system is called an extensive property. Again, I repeat, the property that depends on the mass or size of the system is called an extensive property. Volume, number of moles, mass, internal energy are examples for extensive properties. Again, I repeat, volume, number of moles, mass, internal energy are examples for extensive properties. Next one, intensive properties. The property that is independent of the mass or the size of the system is called an intensive property. Here, the property that does not depends on the mass or size of the system is called an intensive property. Refractive index, surface tension, density, temperature, boiling point, freezing point, molar volume are the examples for intensive properties. Again I repeat, refractive index, surface tension, density, temperature, boiling point, freezing point, molar volume are the examples for intensive property. Here we are having the typical list of extensive and intensive properties. For extensive properties, we are having volume, mass, amount of substance, that is mole, energy, enthalpy, entropy, free energy, heat, capacity. For intensive properties, we are having molar volume, density, molar mass, molarity, mole fraction, molality, specific heat capacity. This tabular column gives the list of extensive and intensive properties. Let me stop up to this topic. The remaining topics that we will discuss in our next video. Thank you.